The exam, it's still a school day, and I expect you to be respectful enough to be paying attention. Okay. So problem number one, I'm on the additional review. Find the range. Now this question could incorporate many questions. This is a trigonometric equation. Tell me what you know about this.
Start that pi, it's such a positive pi over 4.
Yep, on a period.
Starts at positive pi over 4.
Have some paper.
Now what does that do?
It's raised up.
That's raised up 1. So it's not gonna, the point's not gonna be here, it's actually gonna be up here. And it's gonna end somewhere out there. That's really not part of this question. We can talk about where that is in a minute, but we're finding the range. All right, so think about that for a second. So I've got this sine curve, it goes up and down, okay, like this, right?
Yep.
What is its amplitude? 4. So since it's starting up 1, it's actually going up to 5, and then it's going down to, my picture's not very good, it's going down to -3. So for purposes of this question, what is the range?
-3 to -5.
The range is -3 to 5. Because range is top to bottom.
Wait, are those included? Because I thought those are asymptotes.
No,
Those are?
included. Those are points.
Why is it 5
Those are
negative?
included.
As it was raised up.
Signs don't have any points, there's no asymptotes in that picture. All right? Number 2, find the coefficient of the third term of this expansion. This was on your test. And, okay, let's take a deep breath. This is not hard.
It's not hard.
If we wrote the whole thing out, we would have a whole bunch of terms, and they would all have a 2x and a -3y in them. All the terms would have that. Along the line, there will be a third term. So there's going to be a first term, and a second term, and a third term. When I expand to the 5th power, I use the 5th row of Pascal's triangle, which is not much. I mean, it's not like the 50th row or something, just the 5th row. So here is the 5th row, and I want the third term. So I'm going to have a 10. Then, okay, 10 is not the coefficient of the answer, because there's a 2 and a -3 thrown into the mix, right? So we gotta figure this out. Here, right here, first term, the power on the 2x would be 5. Here it would be 4, so on the one I want, it is 3, and then that is a 2. So the coefficient is going to be the 10 times 8 times 9. So the coefficient is 720. It's all those pieces.
Can you explain how you got the equation?
Count it down. 5, 4, 3. When you expand it, the power on this is going to start out x to the 5th. And that's going to be x to the 4th and x cubed.
Oh, okay.
Would it be 720 x to the 3rd, y to the 2nd?
It asks for the coefficient.
Oh, just go.
So the term would be 720 x cubed y squared, but it asks for the coefficient, so that's 720. All right, how many ways can you are special be arranged? We know how to do this, right? We just count up how many
There are
letters there
factorial
are.
over.
6, 7, 8, 9, 10, 11, 12, I think 13. And then, oh, I know why I put this on here. And then we divide by what? What do we have?
The double letters, so the 2 E's.
2 E's.
2
A's.
A's.
Is that it?
Yeah.
Okay. When you divide this on your calculator, make sure that you are dividing by both of those. All right? It's a 2 divisions. So it's 13 factorial divided by 2 factorial divided by 2 factorial. So it's a giant number. $1,556,755,200. But make sure you type that in correctly. Number 4. Find the height of a flagpole if the angle of elevation of the sun is 42. We have not done one of those since January.
Yeah, it is.
Remember that setup? Find the height of the flagpole.
I know
So
there's
you
a
can
sign
see
or
find
something.
one
Angle
eighty.
goes here.
90 plus 42.
Wait, I know something else. The shadow is 9.6 feet long.
It's tan 42.
So this is gonna be a tan. So tan
Yeah,
42
goes, next one up.
is X over 9.6.
Yeah.
Because what's tangent?
Toa.
To what opposite over here.
Times by 9.6.
So
Yeah. Oh, yeah.
9.6 and 42. Do be sure that your calculator is in degrees, because that is a degree measure. So we get 8.64,
Yeah.
and that would be feet. All right, number 5. By the way, since I made a specific sheet here, and we're doing them all, what do you think's gonna be on the exam?
All these questions.
Who's gonna be on the exam?
Exact same question. The
No,
exact
not the
same.
exact same question, but these are gonna be on the exam. Now,
You
there's
would
other
see-
stuff on the exam too.
How many questions are on it?
100.
I heard it was 25 questions.
Airball. That's nuts. Oh my god.
I don't know, I have to count them. I
Airball,
don't know.
airball.
It's not an airball.
All right, number 5.
You're good though.
Dude, someone literally told me.
Sam?
Find the measure of angle B. Now,
The
for
sign.
this problem right here, we did, he said TOA. We did SOHCAHTOA here. Because this is a right
angle.
triangle.
Yeah.
This one is not.
I don't have
So
that.
it's either the law of sines
Or law
or
of
the
cosines.
law of cosines. Look at your given. Do you remember which one it is?
Heroes formula.
Now, Hero's formula would be to find the area. We're not finding area. If you are finding an angle or a side,
Sign X.
you're gonna use the law of sines or cosines.
Oh.
Who remembers how we decide which one it is?
If it's ASS or SSS.
What do we have to have in
An
given?
angle, you have to have an angle.
You have to have an angle and its
side.
opposite
Side.
side. Remember, you have to have a pair.
But we don't have that.
We don't have it, so it's not law of sines, it must be law of cosines. So, we're doing angle B, so cosine B is out here. 16 squared equals 10 squared plus 12 squared minus 2, 10, 12. Remember that? You haven't done that in a
Yeah,
while.
I bet I remember that.
But that's what we review
Do we
for,
need
so
to,
we can go back and
have that memorized?
study, right?
Wait, so we don't get the formulas though, right?
So you get some formulas, and on Monday, I will show you the reference sheet that you get,
I'll come one
okay?
day.
I don't know if I'm
Now.
doing that.
To solve this one, it isn't hard. You just have to make sure that you are doing things in the right order. A huge temptation is to add these two together and subtract 240. Can't do it. You can add these two together for sure, but don't be subtracting because this one has a cosine.
Cosine B.
So we're gonna subtract the 244. and divide by negative 240. And then, how do we put that into our calculator? We wanna find an angle. What do we have to press? Inverse. So second cosine,
Had your
12 divided by negative 240, and it's 92.87 degrees. As most of our tests, you will have a calculator for part of it, and you won't have a calculator for part of it.
Will there be like two different papers?
One
Bless
was
you. Thank you.
now, guys, what is this asking me to find?
The inverse of that.
Find the angle,
Bless you.
find the angle whose cosine is √3/2. Find the angle
I got
whose
that.
cosine is √3/2. 30 degrees.
Yeah, photomaps not gonna work on the wall, so.
Alright.
12 for negative.
Now,
What if it was a
some
regular-
of this is on the review sheet, I'm just double making sure that we practice it, because I know this one's on one of the review sheets anyway. What am I doing here?
Finding the determinant and flipping.
Finding the inverse, and to find the inverse,
We're talking about.
okay, to find, that is not a calculator problem, so don't type it in.
No, I'm
Talking about the cosine.
Alright, so here we go, we're finding the inverse, 2 steps.
Determinant.
First, we find the determinant, so we
6.
take 1 times 5, negative 3 times 2, and subtract them.
11.
So we get 5 plus 6, we get 11. Now we build a new matrix by doing some changing around. So these two change,
Negative 2.
that becomes
3,
positive,
negative 2.
that becomes
Yeah,
negative.
divide by 11.
And then I take each of those numbers and divide by 11. And that is my inverse. Would everyone agree with that? Again, I'm supposed to be jogging some memories here. You're gonna star what you forgot. Oh, I need to back and study that. I need to review that. All right, now the next one, we are going to multiply A times B.
Okay.
So A is that one,
This is the one that
and
tricks me.
B
This one tricks me up a little bit.
is this one. Okay?
Yep.
Now, before you start, make sure you can. So this is 2 by 2, this is 2 by 3. Okay? I'm gonna multiply. I can, and the answer
2
is
by 3.
2 by 3.
It's row and column. Row to column.
So row times column.
Yeah,
So 1, 2, that's my row,
yeah.
times 1, negative 1, that's my column, and add them together. Negative 1.
Oh, is that simple? Okay.
Yeah. And then, same row, this column. So 1, 2, 2, 1,
4.
that makes 4. And then, same row, this column. So that makes 11. Then we go back and do the same thing, but it is this row now. So negative 3, 5 times 1, negative 1. Negative 3, 5 times 2, 1. And negative 3, 5 times 3, 4. Let me figure out what all those are. Negative 8,
1. Oh.
negative 1, and 11. So again, we're jogging memories here. Bringing back fond memories.
So we multiplied 3 buckets of chicken on 4.
All right, number 8. Negative 2, 3. negative 2, 3, right here,
Prism.
is on the terminal side of an angle. That's the point, negative 2, 3. Find the cosine. So I'm gonna drop this angle, or drop this perpendicular straight down. This is negative 2, and that's 3, because that's how I plotted the point. Left 2, up 3.
But that, well, no, you don't.
Pythagorean theorem says that will be
Root. Root 13.
13,
How?
4 plus 9.
Wait.
And cosine is adjacent over hypotenuse. So the cosine is negative 2 root 13 over 13.
Yes.
9 was just on your test. What does this mean? What am I supposed to be finding?
The 15th term.
No,
Oh, wait, no, you're supposed to be.
I'm adding them up.
Yeah.
I'm adding them up.
So 15 over 2.
Now, what am I adding up?
You plug in
Before I jump
one.
into a formula,
Yeah,
Dana,
my bad.
I have to make sure I know what kind of sequence I
No,
have.
you're right.
Plug in
You're
one.
So if I
you're
put
right.
in 1, I get negative 1.
Yeah.
If I put in 2, I get 1.
Yeah.
3 gives me 3.
So she's supposed to.
And do as many as you want till you figure out what's going on. Would you say arithmetic?
Yeah.
So now, Dana, I know which formula I need.
15 over 2.
So this one.
Yep.
So how many terms am I adding up? Going
15.
from 1 to 15. There's 15 of them. So 15 over 2. I already figured out the first one's negative 1. And now I need the last one. And I can get the last one by plugging in
27.
15.
Yeah.
And that gives me 27. And then I can type that in on my calculator. That would be a calculator problem.
26.
Type it on your calculator.
7.5. 122.5.
No, it's 195, I think. Yeah, you see something, yeah.
Yeah, I was just got in my head.
I'm saying.
You're doing.
And then the last one on this sheet.
I tear my knee in 4 different places, and then next week I tear my knee in 4 different places. How many times did I tear my knee in 1 week?
Find the exact cosine of 75.
I thought that
So this is gonna be on the no calculator part.
Because that's what you want.
Yeah, review.
This is gonna be on the no calculator part. So we aren't gonna just type it in. We're gonna have a means of figuring out the cosine of 75. Who remembers?
That's in the first
I know, you
one.
put it in
It's
triangle.
in the
Oh,
first
yeah,
part.
it's like it's oh, you put it on the clock.
The different.
The first part.
Okay, so
It's
0,
the-
90, 180, 270.
It's in the first,
I can't hear Pat because of the.
it's in first.
Oh, the U and V.
First quadrant.
Well, 75 is in the first quadrant, but 75 is not one of my
It's
special
30 and
bills.
25. You're 30 and
There we
25.
go.
Jeez. Guys, do I have to give every single answer in the class?
As 30 plus 45.
Yes.
Now,
Oh, no.
Well, then U and V would.
Can you stop?
there are other ways to get 75, but that is probably the easiest. Okay? Don't say 60 plus 15, because 15 is not special. You gotta use your specials, okay? All right, now, then you're gonna, that for sure is gonna be on your formula sheets. You're gonna look at your formula sheet, and it's gonna say cosine first, cosine second, minus sine first, sine second. Okay? That you're gonna get right off your sheet. It's right there on the sheet.
And so that would be,
Now-
if I remember 45 was like.
You start plugging in the values. So if you want to draw your triangle, you absolutely can. So in a 30, 60, 90, we know approximate 30 is 1, hypotenuse, root 3. Those are the ratios in a 30, 60, 90. And then a 45, 45, 90. This is the one that we probably don't need to draw because the sine and cosine of 45 are the same, right? And they're both root 2 over 2. So cosine is root 2 over 2, sine is root 2 over 2. All right, what is the cosine of 30?
Negative 3 over 2, or
Root 3 over 2.
3 over 2.
Yeah.
And the sine of 30 is
1/2.
1/2. So if you remember doing these,
I do.
we get root 6 over 4 minus root 2 over 4, and we normally combine those into one fraction. You can't combine the root 6 and the root 2. Okay? But remember getting answers like that?
2 root 2.
We always get answers that look like that.
Yeah.
All the time. Because they're always,
Okay.
there's only a certain.
So that's right. So that's the additional. I wanted to make sure we did that.
Yeah, we got that one.
Okay. Now, as you were doing your review,
John Frederick.
what are you doing about John Friedrich Gauss?
I'm just reading the back of the page.
He was a pretty special guy.
That's right.
Jack Goff.
No, not.
Oh, John?
That
Oh
is-
my God.
That's Jack's name.
Oh,
Jack is
oh,
the other
I
guy that
thought you were
graduated.
talking about Carl Friedrich Gauss.
Oh.
No, you're talking about someone else.
Jack Goss. His name is John Frederick.
All right. Who else? Or who found a question? Patton, I'll start with you,
Since you
since
did
you
it.
did the whole sheet.
Yeah.
So on your reading sheet, Patton, which problem did you have a question about?
I'd say probably number 16.
16? All right, so 16,
5, 7, 136.
problem 16, listen. Problem 16, there are 32 students in a math class. So here is my box of 32 kids. 17 of them love both logarithms and polynomials. So there are 17 kids that love both. 20 love logs, and 22 love polynomials. Now, if there are 20 kids that love logarithms, but 17 of them are already counted, this whole circle is a logarithm circle,
Three there.
and there must be 3 here.
Yep. Those 5.
And then if there's 22, there must be 5 here.
7 people don't.
How many people are inside those circles? 25.
7.
How many kids are in the class?
7.
So there are 7 kids who are out here
That was
and
like
don't
the-
like.
What was the one?
The choir and
All right. Ronan,
Did we do the area one yet? Area of the triangle?
which one?
Number 9, any of 9. Did we do this?
Did you say, did we do this?
No, like on the package.
Number 9. So you want to do A or B?
Let's do, or A. We'll do A.
A? Well, a little bit ago, I had a problem on the board that looked like.
Yeah, I know,
A little bit ago, we had a problem on the board that looked like A. But our job wasn't to find the area, our job was to find one of the angles.
Yeah.
So we used the law of cosine. Now that we're finding the area,
Jake, stop yelling at them.
we will use Hero's formula. So how does Hero's formula work?
Oh, is it the,
It's you add per.
you add all 3 and then divide them by 2?
Divided by-
36.
So it's
So the
23.
perimeter
18.
is 36,
And then divide by 2.
which means the semi-perimeter is 18.
And then 8 minus 2.
Start with 18. and then 18 minus 15, 18 minus 10, 18 minus 11. There's 4 numbers under that radical, so you gotta start with the 18. And every time I do this, or you kids do this, people put these numbers into the formula. They do not go in there. Those numbers never go in. Add them up, divide by 2, and then take that number minus each side, type it all in, square root it, and that is the answer. 54.99. All right, back to you, Patton.
No, it's not a question, but for that one, I did the law of cosines equation.
To find the angle?
Yeah, and then I did that, and then when I got the angle there, I did the law of the area.
1/2 side sine? Absolutely. Takes a lot longer, and as long as you don't have any round off there, it's fine. Jake?
11, same page.
11, how many triangles are possible? What could the answers be to this problem?
1, none, or 2.
Yeah, 1, none, or 2, that's exactly right. You gotta figure out which one it is.
Don't try to forget how to fucking find.
Whoa, language.
So Elijah, I feel really badly for the people who are trying to pay attention, because I am ready to just sit down and stop talking, which some of you may wish, oh, please do that. But I know, and I'm not bragging, but fact is fact, I'm gonna get an A on this exam, okay? I don't need to do this. I'm not doing this for me. Who am I doing this for? You. And if you don't want me to do it, I'm fine with that. I got 1 billion papers I gotta get graded by the end of the day, and I'm ready to go. Okay, so Elijah's already said this is gonna be a law of sines. Look at that, that's law of sines. So sine 79 over 15 equals sine, I'll just call it A, I don't know what it's supposed to be called, over 16?
Yep.
So, I'm gonna cross multiply and divide, so I'm gonna have 16 sine 79 divided by 15. Now, I need to inverse sign that. Remember, this is just gonna be some decimal. I need the angle, so I need to do what I did earlier. Second sine, so second sine, 16 sine 79, close parentheses.
Bless you. Bless you. Appreciate it, guys.
What'd you get?
5.549.
Whoa, here.
I got
What'd you get?
I got 1.0.
You didn't second sign it.
My second sign, I
Oh, it's just the angle.
Aiden and I got error. What does that mean?
None.
I got error as well.
So what was the question? How many triangles are possible?
Zero.
Zero.
I got another
I was wondering why I got error.
25. Area of a rectangular octagon.
25. Okay, there is no such thing as a rectangular.
Regular octagon.
Regular Jay, tell me.
That's on record, that's on video.
Tell me what a rectangular.
No, that's really embarrassing.
Rectangular octagon. You gotta like send that to us in your email. You just have one bloopers, all the
That
bloopers.
is really embarrassing. There's a lot of pictures.
On the area of one and multiplied by how many steps?
Okay, yes.
Yeah.
So clearly, they've drawn in one radius, but clearly we could draw in the rest of them. And when we did that, we would form a bunch of triangles that are all the same size. They're all exactly the same. And all the segments I drew in are 10. So if I look just at this triangle right here, I know 2 sides are 10, And I know this angle. What is that angle? 45. And why is it 45? Because there are 8 of them in 360, and 360 divided by 8 is 45. So the area of the triangle will be 1/2, 10, 10, sine 45. Then I will type that in, and then multiply it by 8.
Easy enough. 4 ground cube.
So I got 282.84. Is that right? I have no idea. Oh, yeah.
35.355.
I got 282.
Yeah, 282.84.
All right. Patton, did you have another one?
I have another one.
I'm asking Patton because he did the whole sheet.
I guess,
German and French.
I guess 1B.
So we are going to have to
1B.
Yeah.
simplify. Yes.
Oh, no.
Oh,
All
not
right,
this
we're
again.
gonna simplify this. Now, what do you remember? Do you remember that we don't do anything with sines and cosines?
No, 10 equals
So
sine of
cosine is gonna stay the same.
10 equals sine of
Yep. Tangent is sine over cosine.
secant is cosine squared over sine.
Secant squared is 1 over cosine
When we
squared.
get these formulas,
Yes.
And I'm gonna do a couple more problems and then I'll let you take a picture of the formula sheet so you know what's on it.
Cross cancel, and then you can
Alright, so what happens?
crosses out.
Those cross out.
Yep. Sine x squared over cosine squared.
So sine squared over cosine
And that's
squared,
just 10 squared.
which is
Man, you know what you're doing, man. That's pretty good.
we do.
Will it always come back into like 1 term? Or?
alright?
You have to?
Jack, do you need to go see the nurse? Yeah.
No.
Go sit up. Alright, Ronan,
26.
cross that one off. We did not do that. We skipped that because we ran out of time. Cross that off.
Which one are we crossing off?
26.
26.
Jeff,
Hey.
8.
Oh.
Who remembers how to find the partial fraction?
No idea. I skipped that part.
I think James.
We have the original, then 8 plus B.
First thing we do is factor our denominator. We want to factor our denominator. Alright? And then
It's A
the
over
partial fractions will be something over one of the factors plus something else over the other factor. Those are called the partial fractions.
10 plus 5.
Okay? Now we're gonna clear the fractions.
So common denominator.
So we're gonna get a common denominator, so this one is gonna need an x plus 2. This one's gonna need an x minus 3. And now would you agree that in the whole problem, the denominators are the same?
Yeah.
So then I can drop them.
Cross it out.
So 10x plus 5 equals ax plus 2a, I'm doing the distributive, plus bx minus 3b.
And find all that extra.
And then since this is an equation, I know that 10 has to equal a and b, a plus b. Because it's an equation. However many x's you got on this side have to match the x's on that side. And then 5 has to equal 2A minus 3B. Those are the things that don't have X's. So now you solve the system however you
No, just
want.
multiply the bottom by -2.
I would like, that's what I'm gonna do is multiply this by -2.
Yeah.
But I always eliminate, you don't have to. So I got -15 equal to negative, I got B is 3.
You forgot the 2. See that on the board?
And if B is 3, then A must be
7.
7. So A is 7. And B is
3.
3. And there are your partial fractions.
Okay. It's a lot of work.
Caitlin?
Yeah.
Could we do, number 2730?
No, the ones with C's next to them, we don't do.
Oh, okay.
That's CP.
That's CP, yeah, they did a whole extra chapter. All right,
How?
How'd you?
Because,
because we skip around.
yeah, because we can
All
handle the
right,
pressure.
last question, here we go.
4B.
4B. 4B is a no calculator problem, but that's okay, because what we have to remember is that these two logarithms are put together. So since the problem is a subtraction, the logarithms, or excuse me, the numbers will be
Oh, I know this one.
divided. So this started out as a subtraction,
Yeah.
but I make it a division. Then I
How's it
can
division?
drop these out. Don't drop them until you have log equal to log. Then x plus 3 over x equals 5. X plus 3 equals 5x. 4x equals 3, and x equals 3/4. Just doing the arithmetic there, the algebra there.
No, was that last semester where we had like did a loop?
Yeah,
I think that was last.
but that was at the end of last semester, so it wasn't on your first semester exam, it got pushed to the second semester.
How do we just take that supposed to be over house?
Because the original was subtracted, look at your paper. And when logarithms are subtracted, it becomes a division.
If they're added, they're multiplied.
If they're, yeah, if then in addition, we were to multiply them.
All right,
All
now
right.
take a picture of ourselves.
Those of you who are interested in, I'll lay a couple of them out. You can get your phones or your iPads. And here is the reference sheet. It is actually 2 sides. So I'll lay out both sides and just take a
Jake,
quick
you got it?
picture. I'll
It's
lay
like-
out
it's
both
like-
sides. Here, I got a couple copies there.
What's this?
Both sides are laid
It's
out.
like 20.
What is this? Can I wear these to school?
No.
Any
Wait,
address
you'll be able to
will be
tell.
discussed.
I can't wear like
Yeah, the Taco Bell. group
All right,
chat.
both sides are laid out in several places, so you can take a picture if you wish. Yeah, you're gonna take it with them. Oh, yeah, you're gonna take it with them. Yeah, who else is on? He's not here.
You know, what if I just take a picture?
All right. Here is a second review sheet. So if you would like, this is a different set of problems, it's review sheet 2. So if you want one of those, you can take one of those.
Yeah.
And when you come on Monday, if you come, remember it's optional, but if you come on Monday, you have to come with review work done, all right? Don't come in here and think I'm just gonna do problems for you, because I'm not. You have to come with review work done. And I would say, let's just do this, since you need something definitive. You have to do, if you're gonna come on Monday, you have to do at least half of the second review sheet.